Okay, so in this video, we will try to understand how to do all the post-processing for heat exchangers. So here, this is the model. You already know we use this simple model for heat transfer modeling. We have all the domain, the cold, the hot, and walls. So if I click on the wall, this is, we have the, tiny wall in between the hot and the cold domain. So initially, we all know how to do all the post processing basically for the velocity, temperature, or pressure. So now I'll quickly show you how you can do the post processing for this case. So let's say I'll just use the model like this. I will only check this wireframe. If you want, you can actually click it here and then you'll see nothing. Anyways, so let's click on the contours. So then you can select the variable temperature, and definitely we'll select the local temperature, not the global one. And if you click on apply, you see I select only the cold inlet. So what you can do, you can actually click here. You can see this three dot and select all this domain. So click on OK and then click on apply. So previously it was a little different. Like we selected, we created a plane for velocity or the pressure for previous two projects. And now when we're talking about the heat transfer, we need to think about the whole domain, like how it is happening in between the cold and the hot domain. Now, if you want to remove the wireframe, yeah, you can do it. So now you'll see how it looks like. So this is, you see, it's clearly showing the contours. If you want to make the figure, if you want to include more contours, you just increase the number of contours. So then it will show all the transitions, like how the hot and the cold fluid is going. And definitely you should think about the quality of the figure. Anyways, so this is how you can show the temperature contour, okay? And yeah, so you can do that. If you want to show some volume rendering contours, so what you can do, you can just uncheck this. So for this volume rendering, select the variable temperature and then the local temperature and see how it looks like. This is something more, you see this, it looks nice one, but in this case, I would suggest you to select the wireframe for better view. So you look here how it looks like. So for if you use the volume rendering one. Anyways, we will use this contour for now, and what I will show you is how to so we need to answer the question like how the temperature is changing from just one end to another end. I mean the temperature profile. So what I can do, I can create a line from here to here, or I can use the line along the diagonal of the system. So let's go to the location, click on line, and then I'll just put my mouse cursor over here. I'll rotate it a little bit. So let's say I'll select here. I'll select this point, the middle point. So it will automatically, extract all those points. And now so I'm using the hot inlet and the cold inlet. So put your mouse cursor here again and click on there. So if you click, if you click on apply, and then you see this is the line we created. Okay, so that means from this hot inlet to the cold inlet. And now if you go to the charts, then what you can do, you can just select the location here, the line 1 in the x-axis. You select what you want to show. So let's take position, y-axis the temperature, and click on apply. So now you see like how it looks like, the temperature profile looks like this. And it makes sense because you see we found in this line, it is the hot inlet, the temperature is 420, the cold inlet you see 300. So we can validate this. If you go to 3D view and look at this, you see the temperature is higher at this position and the low temperature here. So it's kind of 423 and this is 303, something like this. So look here. Yeah, so this is slightly, this is 300, so it should be kind of 303, and this is 423. So it makes sense like how it is. So if you have multiple cases, so I would suggest you put wall plots in the same frame and do some comparisons. So this is how you will show the, you know, the temperature profile. But for the contours, the temperature contours, you can actually, I would suggest you present it like this. Don't create the planes, and so I really want to see like how the heat transfer is happening between the hot domain and the cold domain. So if you make a plane and draw the temperature contour on that plane, so it's not correct. Anyways, I'll just create a plane now, and I'll show you what it could be. So I'll use the XY plane like this. So let's say some random values. If we move this one, I'll just move this line. Okay, instead of XY, let's say I think the YZ plane. So we should change this value. Yeah, so it looks like, yeah, I will create a line like this. So move this wireframe. So this is our plane. Now, what you can do, you can go to the contours. Okay, so click on the contours. Instead of this, just select the plane one and see the temperature. Look how it looks like when we created the plane and then we plotted the temperature contour. It's clearly showing. The way I created the plane, it was in the YZ axis. So this is the hot and this is the cold plate. The hot plate is going this way, cold plate is going this way. And it's clearly showing the heat transfer. But I really want to see like for the whole domain, and that's really good. So now we need to solve, answer another question like how to just plot the vector, the temperature. It's we can plot the vectors that in the direction of the flow and the heat transfer. So click on the vectors, select the location plane and the sampling. I will suggest you use the equally spaced, and if we say the number of the variable in this case, you just use the velocity for now, and if you click on that, so move that, put this vector like this, it just creates a number of points, and just click on apply. So this is how you can see how the contour looks like. Yeah, you can see how the contours look like. So it is actually our contour, and if you want to see how it is actually moving, so you can make some animations. So this is the you can see this is so fast, but we can see the other contours over there. We need to make it more, yeah, we need to use more time steps. Anyway, so that's not our target. So you can make it much better. This is actually showing the colors. So you can change the colors from here, and you can use the constant. So you can use the constant, and you can, let's say, if you use the black color, then it will be like more visible like this. You can change the symbols. Like you can change the symbol and the symbol size as well. So let's say if you put it 0.7, so we have some errors just outside. So if you want, you can fix it up. Play, if it is 0.4, then it looks like this. You can make more zoom. So you can do a lot of things. You can change the errors. Yeah, so you can play with it later on. So this is how you can, generate the vector plots for this case. We need to show the the law. Let me check. We also need to answer the pressure contour. So here you can show the pressure contours. So if you go back to the contours, instead of the temperature, you can select the pressure, and that will also show you the pressure contours. It is we have that's the wall thickness. You can increase the number of contours. So for pressure contour, I would suggest to you can create different planes along different axes, and that will give you a much later figure for the pressure contour. Okay, so you can also calculate the pressure drop for weighted post-processing. This is weighted post-processing and weighted presentation. You can calculate the pressure variation, the pressure drop between the inlets and the outlets of the hot and cold domain, and that will be really fantastic. So now the remaining question, let me check what sort of other question you need to answer. So we know temperature contour, temperature profile, pressure contour, vector profile. The heat transfer coefficient. Heat transfer coefficient is you need to use the formula. Okay, so at first you need to calculate this Nusselt number here. You look here, this is the Nusselt number correlation that you need to use. This is called the Diels-Boyle's correlation. This Reynolds number you'll definitely calculate by using your in the inline velocity, your pipe diameter, okay, and the water viscosity that you need to use. You know, the Reynolds number, it is equal rho VD over mu viscosity. The Prandtl number, you know, for water, this is constant value, and this is N. If it is a heating problem, it is 0.4. If it is a cooling problem, it is 0.3. So you need to use actually this formula, and then you can calculate the Nusselt number. Although I believe all of you know how to use this correlation. So once you have these correlations, then you can actually use some formula from the heat transfer book. Like we know the formula to calculate how to calculate the heat transfer coefficient. So I'll quickly show you one here. So yeah, so this is the formula, like how you can calculate the heat transfer coefficient. This is a function of the Nusselt number. So you need the thermal conductivity, you need the hydraulic diameter, and you need the Nusselt number. So we already have the Nusselt number from that correlation. The heat transfer coefficient, you can get it from the tables, and hydraulic diameter, you can calculate it easily. So then you will be able to get the heat transfer coefficient. So this is the formula that you need to use for heat transfer coefficient. And finally, you need to answer the question. You need to connect your results with the existing literature. So you just search. You can use some double pivot exchanger results, and there are a lot of options. You can select the counter flow, you can select the parallel flow, whatever you want. You have two cases. In fact, you need to run 4 different simulation for parallel. So total 4 different simulation for 2 different flow, counter and the parallel flow. So this is the whole question you need to answer for this report. So I believe you understand, and I will discuss more advanced and innovative techniques during the class, like how you can analyze the temperature and the pressure or the vectors in different planes. And I will show you some technique like how you can easily calculate the heat transfer coefficient and the Nusselt number. So that's it for now. I believe you understand, and if you have any more questions, just attend the class and we'll have a chat. So that's it for now.